welcome to Honors Physics Lesson 3.4, Weight and Mass. Alright, so mass, chemistry-wise, defining it as pretty much anything that has matter, right? So mass is the matter that makes up an object. In physics, we talked about it being related to inertia, and this is how much resistance it has to its change in motion, either staying still or moving, whatever. Either way you want to look at it, mass is always going to be measured in some sort of grams, and in here, kilograms is the way to go. Alright, so that being said, let's talk about weight. It's not uncommon for weight and mass to be used interchangeably, but we need a little bit better of a definition for it. So weight is actually the force of gravity acting on an object. So if we look at Newton's second law, where force equals mass times acceleration, we're looking at weight as a force. So yes, it involves mass, and yes, it's going to involve something to do with our Earth, but it's not the same as mass. So here in the U.S., we use pounds, but for all intents and purposes, what we're going to use in this class is newtons. All right, here are some examples of a difference between mass and weight. So here on Earth, Roy and Sally. On the moon, Roy and Sally. And in outer space, Roy and Sally. Yay, how fun is that? So let's go back to Newton's second law, where weight is actually a force, so mass times acceleration. So if we're on Earth, our weight, or our force of gravity, is always going to be relative to our acceleration of gravity. If we're on the moon, our acceleration of gravity is a little bit different. And yes, there is still gravity on the moon. How fun is that? So let's see how this relates. So here we have a dog. Maybe it's the cute dog from the beginning. Maybe it's not. I don't know. We'll see. The dog has a mass of 30 kilograms on Earth. So this is how much matter it's taking up, right? That's how much matter is in this dog. This is how much inertia this dog has. If we were to be on Earth, we would have 30 kilograms of mass, and we multiply that by negative 9.8 to figure out our weight on Earth, and we should get negative 294. So again, that is our mass, which is 30 kilograms, times our acceleration of gravity, which is negative 9.8. And that gives us our weight, or our force of gravity. On the moon, it's a little bit different. So our acceleration of gravity is less. And when I say less, I'm referring to the magnitude. I'm not talking about the negative. The negative is just giving the direction everything is pulling down. So magnitude-wise, it is less than on Earth. So in other words, if you drop something on the moon, it's not going to accelerate as fast towards the surface. So mass on the moon is still 30, because mass is not the same as weight. Weight on the moon, however, is going to be equal to that mass, 30, times that negative 1.6. And that gives us our negative 48. In outer space, again, the mass is still the same, right? But we can't all of a sudden lose mass. But why do you feel weightless in space? That's because we are so far away from the center of mass of the object that is creating that gravity, the Earth or the moon or the planet, the sun, whatever, that we're actually in a perpetual state of free fall. And that gives us the feeling or act of being weightless. In other words, that there's no net force acting upon us, or at least really small net force. And that's actually, interesting fact, where that idea of zero gravity comes in, because gravity would be 0.00000 294 zeros. Zero gravity. All right. Thank you for tuning in. I will see you next time. Same bat channel, same bat place. All right. Goodbye.